Good afternoon to all of y'all. In this video, we wish to see what is the loss in kinetic energy in an inelastic collision. Well, we know in an elastic collision, kinetic energy is conserved. But in an inelastic collision, part of the kinetic energy is lost. This kinetic energy manifests as elastic potential energy of deformation. So, we would now like to calculate how much is the loss of kinetic energy in an inelastic collision. M1 and M2 are the two bodies colliding. Initial velocities are U1 and U2. U1 and U2 are given. M1 and M2 are given. And they collide, and after the collision, the velocities are V1 and V2. We are assuming that the velocities are V1 and V2. V1 and V2 are not given. We know for an inelastic collision, when we did the video on coefficient of restitution, we saw that the velocity of separation by the velocity of approach was the coefficient of restitution. The velocity of separation is V2 minus V1 and the velocity of approach is U1 minus U2. So, you have an equation here relating V1, V2, U1, U2. We have V2 minus V1 is U1E in minus U2E. That is one equation. Then we have the momentum conservation equation. Because the net force is 0, momentum is conserved. The final momentum M2V2 plus M1V1 is equal to the initial momentum M1U1 plus M2U2. So we have two equations. From these two equations, we can find out what is V1 and V2 in terms of U1, U2 and M1, M2 and E. E is also given. The coefficient of restitution is given. Now the loss of kinetic energy is initial kinetic energy half M1 U1 squared plus half M2 U2 squared, that is the initial kinetic energy, minus the final kinetic energy half M1 V1 squared minus half M2 V2 squared. So what we shall do is solve these two equations for V1 and V2 and substitute V1 and V2 in this equation, in this third equation. If I call this the third equation, substitute V1 and V2 in this equation to get the final expression. So let us find V1 and V2 from this. So what we shall first do is to find V2. To find V2, we have to eliminate V1. V1 can be eliminated by multiplying the first equation by M1. The first equation is multiplied by M1 to give us M1 V2 minus M1 V1 is equal to M1 U1E minus M1 U2E. The second equation we'll write it here. The second equation is M2 V2 plus M1 V1 is equal to M1 U1 plus M2 U2. That is the second equation. We'll add these two. M1 V1 will cancel. Here you will have V2 into M1 plus M2. Here we shall group the U1 terms. So you will get M1E plus M1 into U1, and here you will have plus M2 minus M1E into U2. So that will give us V2 is equal to M1E plus M1 into U1 plus M2 minus M1E into U2 divided by M1 plus M2. That is V2. That is V2. Similarly, we can find V1 by multiplying the first equation by M2. That will eliminate V2 and get it. So, the first equation multiplied by M2. First equation multiplied by M2 will give us M2 V2 minus M2 V1 is equal to M2 U1E minus M2 U2E. We'll write the second equation below that. M2 V2 plus M1 V1 is equal to M1 U1 plus M2 U2. So we shall, to eliminate this, we will subtract this, minus, minus, minus. So this goes, and you will have here minus M1 plus M2 into V1 is equal to, we will club this U1, this will be M2E minus M1, M2E minus M1 into U1, and this would be minus M2 U2 plus M2 into U2. M2 will be minus M2E minus M2E, and here you have M2, so plus M2, minus we are taking it outside, into U2. That will give us, we can change the minus signs throughout, and that will give us V1 is equal to, I will change the signs here, M1 minus M2E, M1 minus M2E into U1, and here again the sign goes off, the minus sign will get away, M2E, let me write it, V1 is equal to M1 minus M2E, M1 minus M2E into U1 plus M2E plus M2 into U2 divided by M1 plus M2. That is the expression for V1. The interesting thing to note here is that if in the expression for V2, wherever we have suffixes of 2, if you make that as 1, and the suffix is 1, if you make it as 2, you get the second equation here, this V1 expression here. So 2, if you make it into 1, so this will be M2E plus M2 U2. You have M2E plus M2 U2. This will be M1 minus M2E U1. M1 minus M2E U1. M1 plus M2 is as it is. So these are the two velocities. Now we will substitute V1 and V2 in this. So let us do that. I will erase this here. Let me. So I'll have delta K. I'll have delta K as half M1 U1 half M1 U1 squared plus half M2 U2 squared minus half M1 V1 squared. V1, what is V1? We'll substitute for V1 this expression. V1 is m1 minus m2e into u1 plus m2e plus m2e plus m2 u2 by m1 plus m2, the whole thing squared. Now we'll write the half m2 v2 squared. So this will be half m2 for v2 squared. We will substitute this m1 m2 e u1 m2 e plus m2 u2. So for v2 we will substitute this. We will have m1 e plus m1 e plus m1 into u1 plus m2 minus m1e u2 by m1 plus m2, the whole thing squared. Yes, that is the awesome kinetic energy. We just have to simplify this and get a neat final answer. To do this, we shall do one thing. If you observe the equation closely, the equation closely, here you are going to have a u1 squared term, a u2 squared term, and a u1 u2 term. Similarly, here you will have a u1 squared term, you will have a u2 squared term, and a u1 u2 term. Here you already have a u1 squared term and a u2 squared term. So what we are going to do is bring all the u1 squared terms together, bring all the u2 terms together, and bring all the u1 u2 terms together. So let's do that. So this will be half m1 u1 squared. The u1 squared for this would be minus half m1 into m1 minus m2e the whole squared u1 squared by m1 plus m2 the whole squared. There will be one more term, that will be minus half m2, and you will have m1e plus m1 the whole squared u1 squared by m1 plus m2 the whole squared. 1e plus m1 squared. So that is the, this is one term. So this is the u1 squared term. This is the u1 squared term. Now for the u2 squared term, similarly, let's club all the u2 squared terms. You will have half m2 u2 squared, half m2 u2 squared. Now come here, this is the minus half m1 into minus half m1 into this squared, all this squared. This will be m2e plus m2 the whole squared u2 squared by m1 plus m2 the whole squared. We have another term here for u2 squared, that will be minus half m2 and this squared, this term squared. It will be m2 minus m1e the whole squared u2 squared by m1 plus m2 the whole squared. That is the, we have clubbed all the u2 squared terms together. Now we will have the u1 u2 terms. Let us write the u1 u2 term. I will write it here. u1 u2 term. u1 u2 term. There is no u1 u2 term in the initial kinetic energy. There will be u1 u2 term in the final kinetic energy term. So you will have uh, minus half m1 minus half m1 into 2 a plus b, the whole squared is a squared plus b squared plus 2ab. So 2 into this into this. So 2 into m1 minus m2e u1 into m2e plus m2 into u2. That will be one term. Yes. Minus half m1, 2 into m1 minus m2e into u1, m2e plus m2 into u2. Now the u1 u2 term for this expression will be minus half m2 into m1e plus m1 u1 into m2 minus m1e u2, and of course there will be an divided by this whole thing would be divided by m1 plus m2 the whole square. That is what is going to give us the u1 u2 term. Now let us simplify this. Let us see how we do that. First of all, so this term 1 we are now going to simplify. So u1 squared is common. We'll remove that column. Half is also common, and m1 plus m2 squared is the LCM. So we will multiply m1 by m1 plus m2 squared. So you will have this as u1 squared by 2, and here you will have m1 plus m2 the whole square into, here you will have m1 into m1 plus m2 the whole square, and here you are going to have minus m1 into m1 minus m2e the whole square, and here you will have minus m2 into m1e plus m1 the whole square. So let's open this up now. So this will be u1 squared by 2 m1 plus m2 the whole square into m1. This would be m1 squared plus 2 m1 m2 plus m2 squared. This will be minus m1 into m1 squared minus 2 m1 m2 into e minus 2 m1 m2 into e plus m2 squared e squared, and the bracket closes, minus m2 into m1 squared e squared plus 2 m1 squared e, 2 m1e into m1, so 2 m1 squared into e plus m1 squared. So let's multiply this in. So this will be u1 squared by 2 m1 plus m2 the whole square into, this will be m1 cube plus 2m1 squared m2 plus m1 m2 squared m1 m2 squared. Let's multiply this, minus m1 cube plus 2 m1 squared into m2 into e, and you will have minus m1 m2 squared e squared. Yes. Here, let's come here now. This will be m1 squared into m2 into e squared, and this is going to be minus 2 m1 squared m2 e, and this will be minus m1 squared m2. You will find a lot of terms are going to cancel. We are going to get a very neat answer. All this effort is going to bear very good fruit, hopefully. Let's see this. M1 cube cancels. M1 cube cancels. You have here m1 squared m2e and m1 squared m2e. This is plus, this is minus. So this term cancels. M1 squared m2e, m1 squared m2e, that cancels. 2 m1 squared m2, and we have m1 squared m2 here. So let's club that. So that will be u1 squared by 2 m1 plus m2 the whole square, and here you will have 2 m1 squared m2 and minus m1 squared m2, which will be m1 squared m2, and you have here m1 squared m2 e squared, get that term here, m1 squared m2 e squared, we have a term here. Then we have a term m1 m2 squared, so plus m1 m2 squared, and here you have a term minus m1 m2 squared e squared, minus m1 m2 squared e squared. Yes? So if you simplify this, here you have m1 squared m2 as common. So let's take that as common. You take that as common, you will have, I am not writing this expression, I am writing only this now. So this, or will there be space for it? Yes, there should be. Let's see. u1 squared by 2 m1 plus m2 the whole square, and here you are going to have m1 squared m2 into 1 minus e squared plus m1 m2 squared into 1 minus e squared. That is the expression. So let's simplify this. If you simplify this, I am erasing the first term here. The first term I am erasing. We already started simplifying it, so we don't need that. So I'll clear that. The second term is here. This we don't need. This is the second term. So this will now be, the first term is going to be, first term will be u1 squared by 2 m1 plus m2 the whole squared, and 1 minus e squared is common. So if you remove 1 minus e squared common, you will have m1 squared m2 plus m2 squared m1. Now here m1 m2 is common, So if you remove m1, m2 common, you will have m1, m2 common, u1 squared into 1 minus e squared by 2 into, if you remove m1 and m2 common, you will have m1 plus m2 in the numerator. That will cancel with one of this. You will get 2 m1 plus m2. That is the first term. Yes, that will be the first term. Now the second term, we do not have to put in so much effort because we saw that by interchanging the suffix, by making 2 as 1 and 1 as 2, we can get the second term. So if you made 1 as 2 and 2 as 1, this would be unchanged. Again, if you make 1 as 2 and 2 as 1, this is unchanged. Only thing that is going to change is u1. u1 will become u2. So straight away we can say that the second term is nothing but, the second term would be, yes, you can do the same way, and you are going to get, second term would be m1 m2 u2 squared into 1 minus e squared by 2 into m1 plus m2. That is the second term. Now we have the third term. Let us simplify the third term. I am erasing the second term as well. We have the third u1 u2 term. So let's do that. So what we are going to do is, many things are common, we will take that out. I'll do it here. Here, if you see, m2 is common here and m1 is common here. So m1, m2 and we have u1, u2. So I can bring all that outside. This is the term 3, third term. That will be minus half m1, m2. I removed m2 common here. u1, u2. So that I have put as 2u1, u2. 2 is there, 2u1, u2. And you will be left with m1 minus m2e into e plus 1. Yes. m1 minus m2e into e plus 1. And here again you will have minus half. m1 is common here. So m1, m2 out. And of course there is an m1 plus m2 the whole squared here. Here m1, m2 you have. Then you have 2. Again you have a 2 term here. There will be a 2 also here because the 2ab term. We have missed that. So let me add that 2. So minus half m2 into 2 into, yes, 2ab term. So my minus m1 into m2 into 2 u1 u2. Here you will have 1 plus e or e plus 1 if you write it as this, e plus 1, and here you will have m2 minus m1 e by m1 plus m2 the whole square. So let's simplify this. We will take minus half m1 m2 2u1 u2 by m1 plus m2 the whole square as common, and what you are left with inside is the product of these two. Let's multiply that. That will be m1e plus m1 minus m2 e squared minus m2 e squared minus m2 e. Here again all this has come out as common. We multiply these two terms and write it here. There is a minus we have removed outside. This minus has also gone out. So we only need to retain the same signs. So minus m2e, what will this be? It will be em2 plus em2 minus m1e squared plus m2 minus m1e. That way. So things should cancel. m1e minus m1e cancels here. Minus m2e and em2, we have that cancels. So you have an m1 and minus m1e squared. Club those terms. So you will have m1 into 1 minus e squared, and you have an m2 term and minus m2e squared. So that will be m2 into 1 minus e squared. So you can remove 1 minus e squared common. If you remove 1 minus e squared common, you will have m1 plus m2. That m1 plus m2 will cancel with one of this m1 plus m2 the whole square, and you will have basically, let me write it here, you will have the third term, entering it here, will be minus half m1 m2 into 2u1 u2 by m1 plus m2 the whole squared. Let me write this. This will be 1 minus e squared is common, and you will have m1 plus m2. So 1 this m1 plus m2 cancels with this, and your third term is minus half m1 m2 by m1 plus m2 into 2u1 u2 into 1 minus e squared. So let's add all these three terms now. That is the third term we got it. So if you add these three terms, you have the final answer. A bit tedious, but the final answer is very neat. So T1 plus T2 plus T3. We want term 1 plus term 2 plus term 3. So term 1, let's write it, m1 m2 by 2 m1 plus m2 u1 squared into 1 minus e squared. The second term m1 m2 by 2 into m1 plus m2 into u2 squared into 1 minus e squared. The third term minus half m1 m2 by m1 plus m2 into 2u1 u2 into 1 minus e squared. So a lot of things common here. m1 m2 by 2 m1 plus m2 is common. So m1 m2 by 2 m1 plus m2 is common. 1 minus e squared is also common. We'll take it there. u1 squared plus u2 squared minus 2 u1 u2 into 1 minus e squared. So that will be the final loss in kinetic energy. We can get the expression m1 m2 by 2 m1 plus m2. This will be u1 minus u2 the whole square into 1 minus e squared. That is the expression for the loss in kinetic energy. As we can see, if E is 1, it is an elastic collision. So if we put E as 1, the loss in kinetic energy is 0. Now, the loss in kinetic energy is maximum when E is minimum because it is being subtracted. So, when E is 0, the loss in kinetic energy is maximum. That is the case when the two bodies stick together after the collision and move the common velocity. And in the case of that is called as a plastic collision, and in the case of a plastic collision, or it's also called as completely inelastic collision. In that case, the elastic potential energy of deformation uh, is not at all reconverted back into kinetic energy. So the loss in kinetic energy is maximum. Thank you.